Hey everyone, this is a practice video for regular expression tokens, character classes, and groups, where we would be going over example of each concept learned in concept video with the same name on the channel. We already covered the concepts in previous parts, so in this one we can focus on examples. If you haven't seen that, I would suggest that you do, and link to part 1 and regular expression course playlist are in description below. I'm Ali from Learn Awesome. Let's begin. So here's the list of concepts we would be trying out in this video. So without further delay, let's head to Regex 101 for our practice session. So the first concept to try out is literal characters. A literal character matches exactly itself in an input string. So if my regular expression is just a character B, like this, and input string is ABC, then it would match only the B character in the input string. Here's a quick recap from the previous video for literal characters. So if your regular expression, however, comprises of multiple characters, then the parser would try to match each character in the regular expression with one in input string literally and in the same order, one at a time. So if our regular expression is, let's say, world, and our input string is hello world, then it would match the world part as is. So let's quickly try it out. So let me type world in the regular expression and input string would be hello world. And you can see it matched all the characters in the word world one by one. So if anything changes in between, let's say I introduce a D in between, then the match would stop occurring. So the order of entries in the regular expression do matter. Each character is consumed one by the regular expression parser and matched with the input string. And any match anywhere in the input string would be highlighted here in the regex 101. By the way, if you are not familiar with Regex 101, we have a full detailed introduction of this website in the initial videos on our regular expression playlist, so you can try it out. So just want to clarify that it would match the word once in the input string if the global flag is not specified. So if I have another word here, then it is matching both of these. It's showing two matches, but if I turn the global flag off, then only one match would occur. That is true for both trying out here in regular expression website or in programming. So all normal characters, including one like percentage, pound, etc., would also match except special characters reserved by regular expression syntax, and that is what we shall look at next. So as you can see in this slide, the characters shown here would not match themselves in an input string. Reason being they are part of regular expression vocabulary or syntax, and they act more like instructions to regular expression parser to act differently than literal characters meant to match themselves in input string. Let's try these out and then we shall see what I mean. So I'm going to start with these ones, like the cap symbol. So we can start by having a regular expression ABC cap XYZ, and well, you can see that cap is already being highlighted even when our input string is empty. Reason is stated in the website on the top right corner where it says cap asserts position at start of a line. So cap is an input boundary assertion and is not meant to be considered a literal character by regular expression engine or parser at all. I hope you have seen our regular expression assertions video by now, and if not, please do so. So anyway, cap here would instruct regular expression engine to match the following string only if it occurs at start of the input string. So matching would fail for ABCXYZ, ABC cap, XYZ. It would even fail for XYZ, even when cap asserts XYZ to be at start of input string. In fact, it would only work if our regular expression begins with cap, like this. Now it's working. Since it's assert start of string, so it cannot allow anything to exist before that in regular expression, right? So as you can see, it is working as expected now once it is at beginning of the string. Similarly, characters like static, question, plus, pipe symbol also behave as instructions and not like characters and won't match themselves in input string. So let's check with static symbols. So let me change my regular expression to AB static C and it would match ABC. It would also match A, B, 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 C, but it would not match A, B, steric C. Since steric is a quantifier, meaning regular expression is expecting zero more occurrences of B here, and definitely not steric symbol. Now I just took those two examples to explain the literal versus syntax character difference and won't go on explaining each of these as they are covered in plenty of detail in our other videos in our playlist. So let's shift our focus to the question what to do if we want to match likes of cap or static in an input string since regex is not allowing us to do that. And yes, there absolutely is a workaround, a magic wand in form of character backslash, which can strip off special status of these syntax characters and make them mortal, literal characters in regular expression. How to use that? Just prefix the syntax character with a backslash and have fun with matching. Let's try it out. So in the example that we were trying out, so the static was the special symbol. So if I place a backslash just before that, you can see it is now matching the input string. Same goes for if I had plus and a backslash, now it would match plus C and cap D. And if I prefix cap with a backslash and we have A plus B static C cap D, yes, everything is working just as expected, and all of these special symbols are being treated just like literal characters in our input string and matching. So backslash is used in a variety of ways in regular expressions. It is also used to match likes of newline via backslash n. So let's say I slay backslash n EFG, and here I press enter and type EFG, and you can see it is matching both lines of the input string. We can even use backslash to specify ASCII code in regular expressions. So here I have a list of ASCII code characters and codes from asciicode.com, and we can try some of these out. Here I must clarify that we must use the octal ASCII code, not the decimal one, as regular expressions only support octal or hexadecimal codes for ASCII characters. I don't know why that is, but this is the way things are set up. So I doubt even those with programming background would have heard of octal number system before, but here we are. So in this system, the base is 8 and the numbers range from 0 to 7. So after 7 comes 10, then 11, then all the way to 17, which is followed by 20. So you can look up the octal number system as I'll stop myself here in interest of time. So say I pick up an octal code at random and copy the corresponding character in regular expressions. So let's say I use this ampersand character with an octal code of 046. I go back to regex 101, paste it, and here I type 046 and see it is matching the character in the input string. Alright, so backslash followed by a number is assumed to be ASCII octal code in regex. Note that support varies from parser to parser. So JavaScript parser or this ECMAScript one would not work with octal codes as support has been dropped in ECMAScript 5. Additionally, note that octal escapes can be up to 4 characters long. That is backslash followed by 3-digit octal code at maximum. So 4 characters in total. But that can cause confusion if you are, say, trying to match ASCII characters specified by backslash 1, but then it is to be followed by another character 2 in input string. So backslash 1 is some weird character in ASCII language, SOH, start of heading. Let's take another example of, say, this 12, which is the line feed or the new line character. So say I want to match the letter or digit 3 following a new line. So ideally I would use backslash 12 to indicate new lines. So if I say hello world, you can see this backslash 12 is matching this new line. And if I type 3 here and type 3 here, then it should have matched that 3 followed by a new line, right? Because backslash 12 for new line, 3 with this 3 character. But that did not happen because backslash 123 is the octal code for capital S. Let me quickly show you. Here it is, right? So that didn't work. So to avoid such confusion, you can use zero padding. So where if I introduce this 0 here, then 012 is a 3-digit code which fills the entire space available for the octal code. And this clears all the confusion. And then 3 appears as the next character in regular expression, which is matching the next character in an input string, as expected. Right, I hope this is clear. ASCII codes are also supported based on their hexadecimal code. So the syntax to do it is to use backslash x followed by the hexadecimal code. So let's say I can pick hexadecimal code for S, which is 53, and I type 53 here. And if I have capital S anywhere in the input string, that would be matching, right? We can also use 71, which would, or 6F, since we already have O appearing in our put string, and see, it matches both O's since the G flag is on. What about Unicode characters? For those new to this term, Unicode is an extended version of ASCII code and has an absolute ton of characters covering all languages in the world and a whole lot more like emojis and icons. So I have this list of Unicode characters open in Wikipedia, and you can see there from this scroll bar, there's an absolute ton of support for all kind of weird symbols, right, and languages. So again, you can use backslash to specify a 2-digit or 4-digit Unicode character code, but you have to use backslash x to instruct regex that following would be a 2-digit Unicode character code, and this overlaps between the ASCII and Unicode. So until 2 digits, the behavior is the same for ASCII and Unicode when it comes to hexadecimal codes. But in case you are about to use a 4-digit character code, then you must use backslash u followed by the 4-digit hexadecimal code. So let's pick any character at random. So let's look at this spider one, paste it somewhere here, and it is 0436. So if I type this, and I'm getting this error on backslash u because this token is either not supported by the selected flavor or by regex 101. Right, so again, the problem is that this is not working because of varying support for syntax between regex parsers. So while backslash u works for most parsers, it does not work for this PCRE2 PHP the same way. And for this particular language, we need to use weird syntax backslash x followed by this 4-digit character code in curly braces, which would make it work. But for most other languages, like ECMAScript, Python, .NET, you can see this backslash u notation works. So there's no standard as such. Different parsers have different ways, so we would stick with the notation. So beware of which parser you would be working with and adapt accordingly and test to avoid any surprises in production. Right, near the end, we need to try out the forward slashes as they are also one of the characters that need to be escaped as they act as delimiters for regular expressions. So again, if you want to use forward slash in a regular expression, we need to escape it like any other special character. So if let's say I have hello forward slash word and I make this on a single line, remove this special character, and so it works here and works in Python but not in JavaScript or PCRE or PHP. So to get that working in all flavors, we need to escape it using a backslash. So now it works with all three of these as well as Python, .NET, and all the others. Right, last but not least, all this magic wand stuff elevates the status of backslash above mortal characters itself. So this is not the one to be left behind and needs to be escaped to be usable as a literal character match. So if let's say I say this, I want to use backslash in my regular expression, I need to escape it itself. So it would turn into a double backslash, but that is just fine. So as you can see, it is working now and it would work in every language, just like the forward slash. So in the concepts video, we discussed the dual nature of backslash, that it can take powers away from special characters, but it can also give power to some ordinary characters as well. So case in question, the word boundary. So let's first see what word boundary assertion is and how backslash is doing the magic here. So let's head over back to Regex 101. I'm gonna get rid of all this and just introduce the letter B, which matches the B character literally, but if let's say I introduce a backslash behind it, then it becomes a word boundary assertion, which if we can read the description, backslash B asserts position at a word boundary. So word boundary is start and end of any word. So it is behaving as a special character now, which it wasn't before. So if let's say I change it to something else like hello world, you can see with these purple markers where the word boundary is being identified, and you can see we are getting 4 matches now. One at here, one at end of hello, then start of world and end of world. Right, backslash n is another special case which is used to match new line character in input string, and you saw it in action in our previous example using its ASCII equivalent backslash 12. Note that backslash 12 is the same as backslash n. So if you recall, we had our regular expression like this, and if we change it to backslash n, then it matches the new line character, which is separating these two lines. All right, here are some more examples of escaped characters with special meanings, some of which we tried already and some await our attention, so let's go for it. So let's start with backslash t, which matches any digit 0 to 9. So if I go to regex 101 and introduce uh, some numbers in between and change it to backslash t, you can see that it matched all numbers wherever they appeared in our input string. All right, next up we have backslash w, which matches a word, and the definition for a word is any letter A, capital A to Z, small a to Z, 0 to 9, and underscore. So if we go here and change it to backslash w, you can see it matched every word in our every letter in our input string individually except the new line character. So it's also gonna match underscore, but it's not going to match, let's say, these brackets, ampersand, gap, percentage. So anything alphanumeric and underscore it's going to match and nothing else. Then we have backslash small s, which matches any white space or line terminators. So we can have a look. So if I do backslash s, you can see it's matching the new line character, but it's also going to match space character. It can also match all of these like backslash f, which is form feed, backslash n, which is new line, backslash r, which is a carriage return, backslash t, which is a tab, backslash v, which is a vertical tab, 85, which is next line, and PZ, which stands for any white space or invisible separator. So in interest of time, we are not going to go into each detail of each of these, so you get the idea. And let's move on. So next up, we have backslash capital D, capital W, and capital S, which are interesting as they match anything but their small case counterparts. So let's say if you want to match a character that is supposed to be literally anything but a number, you would use backslash uppercase T. Same goes for backslash uppercase W and uppercase S. So if we can do a quick example and I show you backslash D, which is matching any number. So if I change it to backslash uppercase T, keep an eye here, it matched anything except what was being matched earlier. Same goes for backslash W and backslash S. So they are really useful in some cases where you are expecting anything but a digit, a word, or a separator in an input string. All right, we are going to skip the coverage of these backslash uppercase A's and backslash uppercase Z and lowercase z since they have limited support and their behavior is very similar to cap and dollar, which has been extensively covered earlier. Backslash zero would also be skipped because it's a programming related construct, which would be covered in programming related videos later on in the series. And this brings us to end of this part of this examples and practice for the concepts from atoms or regex elements videos. So in the next part of this video, we are going to look at character classes, capturing groups, and back references. So don't forget to watch that part because they are very interesting and we'll go over several examples of these and you would be really hands-on once that part is done. So if you like this one, please don't forget to like and share and consider subscribing to the channel. Thank you so much for watching. See you in the next one. Goodbye.